In this video, we are going to learn the important points and lines that we can find and draw in triangles. So, first of all, we are going to draw a triangle. So, let's draw a triangle with two vertices, A, B, and C. This will be our triangle, okay? The first line we are going to draw in this triangle is what we call the medians. The medians are lines that go from one vertex to the middle point of the opposite side. Okay, so we are gonna find the middle point of the opposite side. This is the middle point of the opposite side. And the line going from this point to this point, that's what we call a median in the triangle. Let's draw that median. This is the median. Let's draw the other two medians. So the other median goes from this point to the middle point of the opposite side, which is this one here. And now we draw, we find the other middle point here. This is the other middle point, and now we draw the other lines. The lines going from one vertex to the middle point of the opposite line, from one vertex to the middle point of the opposite lines. These lines, we call them, as I said, the medians. Let's write it here so you can copy the name median. Medians, because we have three medians, okay? So these lines are the medians. And the point where they meet here. All three lines meet in this point. That point is called, let's click on the point, and this point is called the centroid of the circle. The centroid of the triangle, sorry. Centroid. The point where the medians meet. So, medians, the three medians of a triangle, lines going from vertex to the middle point of the opposite line, they three meet in this point that we call the centroid. Okay? Okay. So next, we are going to see a different type of lines. Let's erase the medians, the middle points. The second type of lines we are going to draw are the altitudes. Altitudes. Let's write the name first. Altitudes. The altitudes of a triangle are lines going from one vertex to the opposite side, but they go perpendicular to the opposite side. Okay? So let's see how we do that. Let's draw a perpendicular line from this point to this line. So as you can see, it goes perpendicular. It doesn't go through the midpoint. It doesn't even go through the line. It goes perpendicular. If you imagine that this line continues, this would be perpendicular. This line would be perpendicular to this, to the line AC. If we continue the line, it will be perpendicular to this one. Okay? Let's do the same with this. A perpendicular line from this point to this here, you see, this line goes, this crosses through the segment AB, but it's not necessarily always the case. For instance, in this case, it doesn't cross. As you can see, it goes out. But this one goes through the line, goes across the segment AB. And let's do the other one. From A perpendicular to this, and it would be this line perpendicular. So as you can see here, the three perpendicular lines to the opposite side, they are called the altitudes of the triangle, and they cross, they all three meet on this point, which is called, it is called the orthocenter. Orthocenter. So as you can see, the orthocenter may not be inside the triangle, as in this case. In this case, you can see that the orthocenter is not inside the triangle. In other cases, it might be inside the triangle, but in this case, it's not inside the triangle. Okay? Okay, let's go on with more types of lines, more notable lines, remarkable lines in triangles. This time we are going to talk about the angle bisectors. Angle bisectors are lines that divide each angle in two halves, in two equal parts. Angle bisectors, let's draw the angle bisector dividing angle A there. This is an angle bisector. It divides angle A in two equal parts. This part, this angle here, is the same as this angle here. Okay, let's draw the other two angle bisectors. This is the angle bisector of angle C, and this is the angle bisector of angle B. Let's write the name, angle bisector. Angle bisectors. And we have three, one for each angle bisectors. And the angle bisectors, they meet on a point, this point here, where the angle bisectors meet, is what we call, the point where the angle bisectors meet is what we call the incenter. The incenter of the triangle. That one is always inside the triangle. The incenter of the triangle. It is always inside the triangle. And why do we call it the incenter? Well, we call it the incenter because this is the center of a circle. Is the center of a circle here. This circle inscribed in the triangle is the center of a circle inscribed in the triangle. Let's color the circle red. This circle is inscribed in the triangle. Okay, point D is nothing. It's just a point that I come up with when I draw the circle, but it has no meaning. It's at the tangent point of this side and the circle, the same as it would be here, a point here and a point here, but it has no remarkable meaning. But what has a remarkable meaning is this point, the incenter, because it's the center of a circle inscribed inside the triangle. Okay? And finally, let's go for the last type of lines and the last type of point in a triangle, what we call the side bisectors. The side bisectors, let's put them here. Side bisectors. Side bisectors are lines that bisect, that cut in two halves each one of the sides. That's why we call them side bisectors. The angle bisectors divided the angles into halves, and the side bisectors divide the sides into halves, but not just that. They divide them into halves, but in a perpendicular way. They are perpendicular to the sides. So let's draw the side bisectors. Here, side bisectors. Here, that's the side bisector of this segment AB. This is the side bisector of segment BC, and this is the side bisector of segment AC. And side bisectors, as you can see, all three meet on this point. That point again has a name. The point where the side bisectors meet is called the circumcenter. And why do we call it the circumcenter? Well, there's a reason for that. We call it the circumcenter because it's the center of the circumference of the circle circumscribing the triangle. Okay, let's draw that circle here, there. This is the circle. Let's zoom out to see the whole circle. Here, you see the circle circumscribing the triangle. Okay, as you can see, this circumcenter can be outside the triangle, the same as the orthocenter. It can be outside the triangle. Those features are not shared with the centroid and the incenter. The incenter is always inside the triangle. The centroid is always inside the triangle, but the circumcenter and the orthocenter can be outside the triangle. Okay, so that's been all about the special lines and points in a triangle. Okay.